I'm a hydrogeologist. My motto in life is think out of the box. My name, Marcel. My experience, groundwater and soil contaminations. I'm the creator of Geo RGB, a channel of geographic information systems, GIS, geology, hydrogeology, and contamination. The purpose, the objective, the goal, the intention, the target, the desire. Share my experience and acknowledge to create points of discussion. The Geo RGB community. Promote the use of free and open source software. A free digital society. Provide technical advice to environmental companies. An opportunity for professional growth.
Hello guys and welcome back to my channel. In this occasion I'm presenting the tutorial related to soil sampling techniques using QuantumGIS. In this tutorial we are going to learn how we can use QuantumGIS to create a sampling campaign for contaminated soils. We are going to see some of the algorithms that QuantumGIS can offer us to simplify the mathematical part of the probabilistic sample techniques. This is the third and the last video of the soil sampling techniques, and today we are going to talk about the probabilistic sampling using QuantumGIS for potential contaminated soils. First, we are going to see how we can work with the simple random sampling technique. We are going to learn two different ways of using this technique. Later, we are going to work on the systematic sample technique. After that, we are going to be focused on the stratified sample technique, where we are going to see a couple of examples. At the end, we are going to learn how to use the cluster sampling technique. During the video, we are going to discuss the pros and cons of each of these techniques. However, in this third video, we are not going to create any final map, because we did already at the second video. At the previous video we were talking about the convenience sampling and the strength and weakness of this popular technique. First, we learned how to digitize some petroleum facilities as a vectorial layer. Then, we were discussing how we can define the sample population according to the contaminant and the potential areas of contamination. We learned some of the criteria that we can use to select the proper place to pick up the samples. Later, we labeled the samples and extracted the UTM coordinates from the selected locations to create a proper attribute table. At the end, we work on the map composition to create the showed map. Remember that if you miss this video, you can hit the card located at the top right corner of your screen. Here we have the soil sampling map that we created at the previous video. It is related to the convenience sampling, and as we know already, this is a non-probabilistic sample technique, where we selected the sample locations according to our judgment and criteria. One of the biggest inconveniences of this technique is the bias. In order to avoid the subjective component of the non-probabilistic sample techniques, we can use the probabilistic techniques, where the location of the samples are chosen randomly. Today, let's go to start with the simple random sampling. For this first example, we are going to use the same scenario that we used at the previous video. Then we can assume that at the past, the oil field had a couple of areas where the hydrocarbons were stored in tanks, as you can see over here and over here. Later, the tanks were decommissioned and removed, and now we want to investigate if there is any impacted soils related to the hydrocarbons in these storage areas. When using the simple random sampling technique, all the samples in the population have equal chance of being selected. The question is, what is our population? The population in this case can be defined as all the potential samples that can be taken from the designated area. In this case, the former tank area. As I said in previous video, the potential number of samples depend on the kind of contaminant we are doing the investigation, because each contaminant has its own characteristics and interacts with the environment in a unique way. Also, the type of sediments play an important role. For this exercise, the contaminant is going to be hydrocarbon, and the top part of the soil is going to be clay with sand. Now let's go to define our population. To do that one, we are going to create a couple of shapefile layers. One is going to be for the former tank area, another one is going to be for the background area. The background area is the area between the berm and the lease for both sides, and also here at the top. Then create layer, new shapefile layer is going to be tank area. Save. For the geometry, it's polygon, and the reference coordinate systems is this one. Okay, and now let's go to edit the layer. Press the pencil, then go to this option. Make sure you have the snapping tool activated, and then let's go to copy this one here. Okay, ID 1, and that one it's done. Then let's go to close the edition, save, and now I'm going to create a new layer also for the background. And this one is the background area. Okay, press the pencil again to finish the edition, save, and save the project. Given the type of the contaminant and also the type of topsoil, a population where each member is separated by 5 meters is good enough to characterize the investigated area. To create the population, just go here to vector creation, regular points, select the layer is tank area, use layer extends, tank area. Okay, here as I said, we are going to put a distance of 5 meters between each potential sample, and here we are going to add 1 meter, and here the rest is okay. And let's go to save this one as a population, and run and close. Now what I'm going to do is edit this shapefile layer with this option, and I'm going to remove all the points that are out of the designated area. Just select, then press delete, and now save. Then as you can see here, we have a population of 60 members in total. Now I am going to do the same, but for the background area, but I'm going to pass the video faster. I'm going to save the edition, save, and that's the population I have for the background area. The total number of samples at the background location, it's 149 potential samples. Now let's go to see some of the percentage relative with the population. Then The number of samples we are going to take at the former tank area is going to be 15. And the number of samples we are going to take at the background location is going to be 3. The same as we did at the previous exercise for the convenience sampling. Then if we take 15 samples from the former tank area, what is the percentage of the population that samples represent? Then I created this table here. At the tank area, we have the population of 60 members that it represents 100%. And we are going to take 15 samples. What is the percentage of these 15? It represents 25% of the population. At the background location, we have 149 samples that it represents 100% of the population, but we are going to take just 3 samples. These 3 samples represent just 2% of the population. That is for a distance of 5 meters between the samples. But what happens if we change the distance to 2.5 meters? For example, at the tank area, we are going to have 210 potential samples that is going to represent 100% of the population. But we are going to take just 15 samples. Then this 15 is going to represent 7.1%. And as you can see, that it's a big difference. 25% of the population, it's a good number, and the sample is representative of the population. If you have 7.1%, and in this case I am going to say that this number maybe it's not representative of the population. Then when we decide how is going to be our population, it is very important to be consequent with the numbers. You know, what is your population and how many samples you are going to take. Of course, 2% it's not representative of the population if we want to analyze, in this case, hydrocarbons. But in our example, it is not expected to detect any hydrocarbon at the background locations because there is no petroleum activity in the yellow area. What we are expecting to have here, for example, it's some natural metal concentrations. What happened here, for example, if we have an spill that occurs many years ago, maybe now the hydrocarbons are already degraded and we don't have any concentration of hydrocarbons, but maybe we have concentrations of metals related to the hydrocarbons. It's a residual product of the degradation of hydrocarbons. Then, for example, if we have high values of metal concentrations over here, then we want to compare what is the concentrations of those metals at the background location. And if we have the same values, it means that the exceedances of the metal concentrations at the storage tank area, it's a natural concentration. It's not related with the hydrocarbons. But if we have high values over here and low values over here, it means that maybe at the past it was an spill and we have metals that it was the residual values of the hydrocarbons. Then if we have at the background area just 2% of the population, right, that it's not really important because this 2% it's more related with the hydrocarbon detection, right, that we have at the tank area. Maybe for the background location we have to define a different population because the goal of the background locations is to identify any exceedances that can be associated with natural concentrations and it is not related with petroleum activity. With Quantum GIS we have a couple of options to select the samples according to the simple random sampling technique. The first, let's go to take out the background at the moment and let's go to work with the samples inside of the former tank area. Then from this population we want to pick up 15 samples. That is going to be the first technique. Then we have to go here, write random, and we are going to select the random extract. Double click, then select the layer where you have the information. In our case, the samples are located at the layer population, this one here. And this one is good, and here we want to indicate how many samples we want to take. In this case it's going to be 15, and let's go to save this layer as a population from the tank area or samples tank area. Then save, and let's go to run this one. Close. And if we take this one out, the population one, that's the result for the simple random sampling. Then let's go to put this one on the top. This way to do the simple random sampling technique, it's a kind of mix between systematic sampling, right? Because we have a system here where we place each sample 5 meters of distance at the y-axis and also at the x-axis, right? And it's a kind of a system, right? The way we place the population. But also we can select the samples randomly using the algorithm that QuantumGIS provide us. Then to do that one, go back here, select vector creation, and then we have to select random points inside polygons. Double click here, select the area. In this case it's going to be the tank area. Then tank area is this one. Select the number of samples, 15. And that option is really important, minimum distance between the points. As we said, we are going to choose a distance of 5 meters. And with this way, we are going to have with this method the same population as we created with this method, the systematic one. Maybe it's not 60 samples, but it's a number very close to 60, right? Then this method, the systematic one, and this one that is using the QuantumGIS algorithm is going to provide approximately the same population, right? Then from that population, we are going to take 15 samples. Then let's go to create this one, save as sample tank areas, and that one is going to be number 2. And save. Run. Close. And now we can compare. Let's go to take these layers out because we are not going to use this one. Also the image. And also this one. This one is the one we created with the population we designated. It was this population. And the population was distributed in a systematic way. And from this population we take 15 samples. And that's the random result. If we put the facilities, then for the other one is this result. In this second option, we didn't create any population and we leave the software to take the samples randomly, but with a minimum distance of 5 meters between the samples. Then we can say that the first option is a mix between systematic sampling and simple random sampling. And the second option, it's a pure simple random sampling. Using the simple random sampling, we avoid the problem related with the bias, because the simple random sampling is a technique that is unbiased. We eliminate the subjective part of taking the samples according to our criteria of judgment, as we did with the convenience sampling. I'm not going to do the background location because the way we can take the samples. It's the same as I explained for the former tank area. One important disadvantage of using simple random sampling technique is the presence of clusters. Let me take this one out, put this one out, and this one, and I'm going to copy this one, and I'm going to show you in a different graph. To have a better understanding of the problem related with the clusters when we are doing simple random sampling technique, let's go to imagine a different X scenario. In this new X scenario, we want to investigate all the area inside the list. We know at the past it was a pipeline break, and some of the hydrocarbons were spread at the list, but we don't know where the pipeline break it was, and also we don't know area from the list was impacted. Then to investigate all the area, we are going to do first a simple random sampling technique, and the goal is to pick up 25 samples. Then after run the QuantumGIS algorithm, the result for the simple random sampling technique is this one. And what we can see here is that there are some areas at the investigated area where the density of the samples is high, but there are other areas where we don't have any sample, right? Let's go to mark that areas. We have all this area over here where we have a lot of samples, and also we have this area over here where we have also some samples, but we have all this area where we don't have samples. Also this one, we have here one sample isolated, and also all this area without any samples. Then these areas where we have high density of samples, and also this one, it's known as clusters. Then what we can do is run the software again and maybe do a different simple random sampling again with the software and see what is the result, right? But what happens if we are doing that one many times? We are introducing a kind of bias on the simple random sampling, because we are deciding what kind of pattern we want for our sampling event, and we want to avoid the bias component of the sampling, right? Then to avoid this kind of scenarios, what we can do, it's for example to do a systematic sampling technique, and that's the next thing we are going to see. The first thing we are going to do is define the population. Then go here, vector creation, regular points, double click, select the investigated area that is going to be the list. Okay, then here is going to be one sample every 10 meters. And this one I'm going to leave 0, and then I'm going to create a temporary layer. Run and close. Let's go to bring this one to the top, and that's our population. This one has a total of 121 members of this population. Maybe someone can decide to remove all the population located at the perimeter of the list. It depends on the professional decision, right? Then the next step is to take the samples from the population. As I said previously, in this case I want to take 25 samples. Then what I'm going to do is go here again, select the list. Then in this case I want a sample every 20 meters, and this one is going to be 10 meters. And let's go to create also a temporary layer, close, and let's go to change the color. for a red one. Apply and OK. And that's the samples we are going to take. As you can see, if we go to the attribute table, we have 25 samples. That is going to be quite representative of the total population of 121, even if we consider to remove the population at the perimeter of the list. Now, with the systematic sampling technique, all the samples cover all the list area in a homogeneous way. Then we don't have the problem related with the clusters as we have with the simple random sampling technique. In the systematic sampling technique, all the samples are chosen from the population according to a fixed rule. In this case, let me show you in this graph. In this case, our rule is to have a distance from the list for 10 meters for all the samples, 10 meters here, 10 meters here, 10 meters here, and etc. And then the distance from the samples, it's 20 meters. That's our rule at the systematic sampling in this case. The advantage of using the systematic sampling technique is that the sample location is unbiased. The only thing we decide is the rule for the sampling location, but not the location of the samples. And also another good thing related with this technique is that we can cover all the area in a very homogeneous way. However, there is also some disadvantage related with the distribution of the samples. As we are following a fixed rule to place the location of the samples, we are creating a pattern. And in this case, the pattern looks like this. Let me show you. This is our pattern in this example, right? In this direction and also in this direction and this direction. And this pattern could be also a disadvantage. Let me take this one out. Because, for example, if we have here on the terrain a depression, for example, let's go to imagine that this one is the contour line for the topography, and we have something like that. Here we have a small depression. This one is the contour lines. Sorry, not this one. Something like this. And this one is, for example, 10 meters. And this one is 9 meters, for example. Then if we have a pipe break over here and some of the product go to the surface, then the product is going to take this depression to move, right? And then the hydrocarbon is going to migrate perpendicular over here, right? Then the contaminated area is going to be all this area at the depression. But as we take the sample systematically, we are missing all this area, right? Then with the systematic sampling technique, if there is a pattern on the contamination, could be a problem, and we are not going to identify the contamination. Another example could be if there was a blowout, for example, from the pump jack, maybe the hydrocarbons go in this direction. Maybe we are not going to capture any contamination, right? Because we are not going to take samples from this area. Or maybe if it goes in, I don't know, also in this direction, right? Then when we are doing a systematic sampling technique, we have to consider the potential of existing pattern on the contamination, and that's really important. It means that before to prepare the sampling campaign, you have to know what is the contaminant you are going to investigate and how that contaminant can migrate at the surface, and also how the contaminant can migrate on the vertical, and also how that contaminant is going to interact with the sediments in your site. Then, if we believe there is a pattern in our contamination, and then we cannot use the systematic sampling technique, and also we want to avoid the clusters from the simple random sampling technique, what other options we have in order to cover all the extension? Then in that case we can use the stratified sampling. In this sampling technique, the population is broken into non-overlapping groups. That groups are known as stratas. Then a sample from each group is taken. Let's go to see that one with QuantumGIS. What we want to do first is create a grid. Then double click on this option, create a grid. Then here for grid type is going to be a rectangle, polygon. Then the grid extent is going to be the least. Okay, then for the horizontal spacing we want 20 meters, and also for the vertical one 20 meters. For the horizontal overlay is 0 and vertical overlay is going to be 0. The reference coordinate system is good, and we are going to create a temporary layer. Then run, close. As you can see, that one is our grid, and each square is an strata. That one was for the systematic sample for 20 meters, you know, the distance between each point. What we did is created a grid where each square is 20 meters by 20 meters. The next step is to select this option here, random points inside polygons. Double click, and here what we are going to select is the grid we created, this layer over here. This option is good, and here is going to be just 1 point for each square, and the minimum distance between the points has to be 20 meters, because that's the same as we did here, 20 meters. Then let's go to run, close, and that's the result we get. Let's go to take this one out, and also let's go to take this one out, and let's go to change the color for this one. Apply, and OK. And let's go to analyze the result in a different graph. Then with the stratified sampling technique, what we have is a good coverage for the area of investigation, and also we avoid any kind of pattern on the sampling location. Sometimes we have also some areas where there is no samples. We can repeat the method to see if that can improve a little bit. This method is also really good because it's unbiased, you know, we don't decide where the samples are going to be located, and also has a really good coverage of all the area. Be aware that when using this technique, you have to keep the proportion of the samples according to the size of the strata. Let me show you. In our case, each strata is the same size. Then we are going to take just one sample. But if the stratas are different, for example, let's go to imagine that we have this strata, and then we have this one, and this one. Then from this strata, if we are considering all this one strata, then here we have to pick up 4 samples, and here we have to pick up 1 sample, and here we have to pick up 1 sample. And that's a pretty common way to do the stratified sampling technique. Sometimes they divide the extension in areas according to specific characteristics. Let me show you in a different graph. This one, for example, go take all these ones out. Let's go to imagine that we want to see if there is any impacted soils in this area. Then we are going to divide the area in a different stratas. Then we are going to consider that one. Let me change the thickness. Let's go to think that this one is the strata for the well center. This one, for example, over here, it is the strata for flare pit, for example, for a potential flare pit. Here, for example, is the strata for the drill west disposal area. Here, for example, is the strata for a area of storage some hydrocarbons, for example, some tanks over here. And also, for example, this area is the strata for another potential drill west disposal area, right? Then we have to think that we have to keep the proportion of the samples, right? In this strata, for example, if we take, let me change this one, we take, for example, 3 samples, 1, 2, 3. As this one, for example, is the double as this one, here we have to take 6 samples. And here maybe we have to take 2 samples. And here again 6 samples. And here 5 samples. We have to keep the proportion of the size of the strata with the number of samples. That is a more common way of doing the stratified sampling technique. But in our case, we simplify a little bit the stratified sampling technique, just with squares where all the squares are the same dimension. The last technique we are going to talk about it is the cluster sampling. The cluster sampling is pretty similar to the stratified sampling technique. There is just small differences. Then at the cluster sampling technique, the population is broken down into many different clusters. Then each cluster, it's like each strata. Then a random selection of the clusters is chosen. Okay, let's go to see that one with QuantumGIS. Then go here. Let's go to open this one, and now let's go to imagine that all these squares, it's a cluster. Now what we are going to do is a random selection of these squares. Then go here, random, and then select the random extract. Double click, select this layer, and just select the number of features you want to select. In this case, for example, we know it's 25 squares. Then let's go to say that we want to take just 15 squares. And then run and close. Let's go to change the color for a red one, for example. Apply. And that's the squares the software selected. Then with these squares, then we can make a systematic sample with one sample just at the center of each square or cluster in this case, or just with a random selection inside of each square. Then just to show you, let's go back here, select vector creation. Then here, random points inside polygon, for example. Then select that one, extract it, is this one. Number of samples 1, and minimum distance between the samples, for example, 20 meters. And then run and close. And that's the cluster sampling. Let me change the color. For a green one, for example. Apply, and that's the result. Okay guys, that's the end of this video, and also the end for the tutorials for soil sampling techniques. Thank you very much for watching, and see you on the next one.